In this video, we're going to do some reviewing and hopefully some extending some concepts about multiplying polynomials. We've been adding and subtracting them so far. We have also done some multiplication with monomials back in the previous lesson on exponents, and some of those rules will apply in this lesson. There's really two ways to start multiplying polynomials. Overall, all polynomials can be multiplied using distribution, still applying your exponent rules of the multiplication from your graphic organizer. Specifically, a binomial multiplied by another binomial, though we are distributing, does have this acronym of FOIL, where the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last, which refers to the placement of the terms in the binomials. For our first problem, we have a binomial 2x plus 4 times a binomial 3x minus 7, so we will go ahead and use that acronym of FOIL. So keep in mind that the F, O, I, and L, first, outer, inner, last, refers to its placement in this multiplication expression. I will also show my work in a way that you will see that it's still just basic distribution. When I do my first terms, I'm going to multiply 2x times 3x. Those are the first terms in each of those binomials. My outer terms will be 2x times a negative 7 because those are the terms on the outside of my polynomial or multiplication. Then I will do my inside ones, which is 4 times 3x. Those are the terms that are inside the multiplication. And then my last will be 4 times negative 7, which refers to the last two terms in each binomial. So you can see I'm just distributing the 2x to the 3x and the 2x to the negative 7, the 4 to the 3x and the 4 to the negative 7. To get this multiplication, when we do that distribution, just like with anything else, that's the multiplication. So I'm going to go ahead and do these multiplication problems down below to simplify this answer. So this polynomial expression here comes from the result of each of these multiplications. 2x times 3x, remember we're adding those exponents together, so 6x squared. These 2x times negative 7 is negative 14x, 4 times 3x is positive 12x, 4 times negative 7 is negative 28. So please pay attention to how I handle those positives and negatives, and they became my addition and subtractions. I am now done multiplying, and I need to simplify this answer because I have two x terms. I have like terms. So I'm going to combine my like terms by underlining my 6x squared once. My negative 14x and my positive 12x get underlined twice because those are like terms. And then negative 28 will be underlined 3 times. And that is the simplified answer to this binomial multiplication. This second problem is a monomial, x squared, being multiplied by x cubed plus 4. I cannot FOIL in this problem because FOILing only applies to a binomial times a binomial. So if all else fails, just remember to distribute. The x squared gets multiplied by the x cubed, and the x squared gets multiplied by the positive 4. I'm going to show a little bit more work here just to remember these multiplication rules. You're multiplying the same base, so we add the exponents together to get x to the 5th, and then the x squared times the positive 4 is just plus 4x squared. So that's the answer to that monomial being multiplied by the binomial. In this problem, we have a binomial that's being multiplied by a trinomial. There are several different ways we can do this. Ultimately, it comes down to distribution. It's simply the way you'd like to organize your work. I am just going to organize my work as I go, so I'm just going to distribute here. I'm going to start by distributing the x to each of the terms in the trinomial. Then I will come back and do the negative 7 times each of the terms in the trinomial. Please keep in mind that when I am multiplying with this distribution, I will add the exponents together. Okay, so my blue is what I got from distributing the x, my purple is what I got when I distributed the -7, and I've decided instead of putting the purple part out here and then underlining my like terms, I set them up vertically by my like terms to be able to combine them together to get my final answer of x cubed minus 5x squared minus 19x plus 35. Please notice when we are adding the terms together, when we are combining like terms, the variables and the exponents do not change. We are simply adding and subtracting the coefficients. It's when we do the multiplying with the distribution where my exponents change. Please keep that in mind. We are now going to do the same problem again, this binomial times this trinomial, but instead we will organize our distribution using the box method. You can see that this is very similarly set up to your matrix multiplication that you learned in elementary school. The x, the -7, I will put along this side here, my left side. And then the trinomial of x squared plus 2x minus 5, I will put along the top. It does not matter if you wanted to make this 3 boxes high, then the trinomial would go here with the binomial only on this side. Order of multiplication doesn't matter. This is just a little nicer looking for me, so I'm choosing to do a 2 by 3. Inside the boxes, you do your matrix multiplication, x times x squared, x times 2x, x times -5. So let's get started. X times x squared is x cubed, x times 2x is 2x squared, and x times -5 is -5x. This is the exact same multiplication I was doing in my distribution work in the other method. This is just a different way to show it all. The other piece to this is that if everything is in standard form and you're given nice problems, you can see on these diagonals that you get like terms, and that's what needs to be combined. It's very similar to your matrix multiplication where we are going to add the diagonals together, and I went ahead and highlighted in different colors the like terms. So purple, x cubed is by itself, my x squareds adding together, just adding the coefficients together, the variable exponent does not change. Same thing with my blue x's and then my constant on the end. Exact same answer we got using the last method, just another way to organize your work. Okay, these next 2 problems I'm going to do with you also. Number 4, I have a binomial times a binomial, so I'm going to go ahead and FOIL that. Again, please keep in mind that the FOIL just stands for the first, outer, and inner, and last, which is just the placement of the terms that are going to be multiplied. Sometimes people like to put the second round of distribution, those arches on the bottom. You certainly have that possibility if you'd like. So when I do that, I have 6x times 5x to get 30x squared because I'm adding exponents together because I am multiplying the same base. 6x times 3 is 18x. 1 times 5x is 5x, and 1 times 3 is 3. Now I will combine like terms. 30x squared is my only x squared terms. My outer and my inner, if they're going to combine anywhere and if everything was in standard form, that's going to be where you find those terms that do need to be added together, and the constant most of the time is going to be that last number hanging off of the end. So that's my final answer, because each term is a different product of variables. X squareds are different than x and different than just the constant, so they cannot be combined any further than that. Number 5 here, I have a trinomial times a trinomial, though I am certainly allowed to just go forward into my distribution, which if you are comfortable with that, you are welcome to do so. I'm going to use the box method just to organize my work because I have found that most students prefer that. So I'm going to go ahead and fill in my boxes using my matrix multiplication methods. Now that I have completed the box, just some things to notice. Again, when you are multiplying, which is what you are doing to fill in this box, when you're multiplying, you're adding those exponents together. So that's why x squared times 2x squared is 2x to the 4th. If you do everything correctly, there should be a nice pattern here with your exponents: 4, 3, 2, 3, 2, 1, 2, 1, 0, going down, 4, 3, 2, 3, 2, 1, 2, 1, 0. It doesn't happen all the time, but most of the time it does. So just like with the last time we did the box method, I have some like terms on my diagonals that I can identify, and I can be allowed to combine those together. It's not always set up perfectly on the diagonals, so you really want to make sure that you are paying attention to where your like terms are, but in this case it works out to a nice pattern. This is my final simplified answer, making sure again that we're just adding and subtracting those coefficients. With my x squared, it's -8, -12, and a +1 here. That's where this -19 is coming from. Just make sure you're paying attention to that 1 there and what should be added or subtracted together. So that's what we have for our different methods of multiplying polynomials. Basic is distribution. Okay, there's a silly acronym of FOIL that you can help memorize to keep you organized, and then there's also the box method to keep you organized with your longer multiplications. These next 3 problems I would like you to do on your own and submit them to me. I've made this video part of an assignment on Canvas. This is how I'd like you to submit these problems to me. If you choose to do them on notebook paper, please take a picture of your notebook paper and your work completed and upload that file. Your other choice is to maybe do the work in a notes app on your iPad, screenshot that work, and upload the submission in Canvas. Please do this as soon as you are done with this video. Thank you. And here are your final answers. Please make sure you're checking your work and that they're all in standard form. We will now apply this multiplication rules, the distribution and the FOILing and things to application problems from basic word problems, and including area and areas of shaded regions and shapes.